as you can see, um, the PAC camera is able to detect the stop sign, and the FPS is about 4.5. I noticed the FPS will drop significantly if the Raspberry Pi overheated. The way I overcome this problem is to add a heatsink on top of the microprocessor, as you can see here. So I added two of them, one on the main processor and the other I think is on the secondary processor. I found they are very effective to improve the FPS.
Hello, this is the code walkthrough for CS437 Lab 1 self-driving car. This is the main function. So first I import a bunch of libraries that is required for this project. And I also import some functions from detect3 file. And this program here is I modified based on the TensorFlow Lite object detection algorithm. And then we define some variables. The ongoing step is for the servo motor. The speed is the car driving speed. Traveled, it's the distance that the car have traveled. Target is the target distance we want the car to travel. In the main function, first we declare the traveled variable as a global variable so that we can keep update this in the loop. And while the travel distance is smaller than target distance, we will keep run the code in the while loop to keep the car moving forward. So first we run this object detect function to get a list of the detected object by the TensorFlow Lite algorithm. If the stop sign is in the list returned by TensorFlow Lite, we know there's a stop sign in the front. And in this case, we will stop for 2 seconds, and then we will drive forward for 10 centimeters to basically reach the stop sign, and we will stop again for 5 seconds, and then like before we're moving forward, just like we do when we run into the stop sign, we stop twice. And then we, after this, we will enter the routing function. The way I design this is first I create a NumPy 2D array with all zeros, and then I scan I use the ultrasonic sensor to scan the area in front of the car from negative 40 degrees to 40 degrees. And this will give us a distance at a certain angle. And if the distance return value is -2, that means something's wrong. It's either the object is too far or too close to the ultrasonic sensor. In this case, we just drop the value and continue. And for the scope of this project, we don't need anything further than 100 centimeters. So if we capture anything, we just drop it. Also, sometimes the sensor will return a negative value. So it makes no sense, we will drop it. At this point, we know we have a good reading, and we will convert it into the XY coordinate and assign 1 to it, so that we know there is upscale in this coordinate. At this point, we have the map in front of the car, and we can start to run the routing algorithm. The way I design this is first I will check. Let me borrow this. First, I will check if the front is all clear. So basically, we will check the area like 0 to 20 in y-axis and 40 to 60 in the x-axis. So basically this area. So if all the value here is 0, we know there's nothing in the front. We can drive forward. So we will just drive forward for 0.5 seconds and also increase the total travel distance. And so else, that means we have something in the front. We don't know it's on the right or on the left. So we'll enter this this else statement. So here I will first check if something is on the right. The way I do this is I will sum all the ones in like this area, like as you can see from 0 to 20 and 55 to 70. So I will sum all the ones in this area. If the sum is greater than 4, then I say there's something on the right. The way the reason why I do this is because sometimes the sensor will return 1 even though there's nothing there. So basically in this way we can give our algorithm some tolerance, because if there is upscale on the right, the return will be like 10, 20. It definitely will greater than 4. We do the same thing so if we find something on the right, we turn to the left. If we find something on the left, we turn to the right. And sometimes none of this is true. Like I said, because sometimes the sensor will return the wrong reading. In this case, we just continue to run again, and in most cases, the algorithm will figure out by itself. It will clear up the wrong reading. Once we finish this, once we jump out of this while loop, we know we traveled enough distance and we reached the target. And we just print arrived at destination. Okay, that's the code walkthrough. Thank you.